So, who do you imagine when I ask you to draw a scientist? Maybe it's someone with crazy hair, wearing lab goggles, surrounded by chemicals. For the 5,000 students surveyed in the original Draw a Scientist study, many of their drawings look similar to the ones above, but with one key missing element. Only 28 of those drawings featured female scientists, all drawn by female students. While the study was conducted in 1983, studies conducted today still show that children are drawing twice as many male scientists.
Naturally, many people asked why there were and are so few female scientists drawn. But lack of female representation in STEM is not only a problem of perception. Overall, women make up only 24% of the STEM workforce. The graphs on this slide point to two critical moments in girls' STEM educations. The line chart at left shows that in high school, there's essentially no difference in the number of math classes that boys and girls take, while the pie chart at right shows that in college, girls make up only 40% of those pursuing STEM degrees. Clearly, something is happening between these 2 points, and GYM exists to try to address that. Other groups exist to address the lack of representation of women in STEM, but GYM is different for a few important reasons. Firstly, we directly address gender identity through our Girl Talk sessions. During these discussions, we talk about stereotypes and stereotype threat, cultural norms, beliefs about intelligence, and self-assessment. We also have only female mentors. Research has shown that having female mentors is essential for girls to continue on a STEM path. With these female relationships, we hope to address both of the points I mentioned earlier: middle and high school for the students who come to our workshops, and college for the students on our BAS teams. Finally, we focus on problem-based learning, which for us means that we do interactive math problems in groups.
So let's take one of these math problems. Imagine we're standing in a rectangular room. In the wall behind me, there's a fly 1 foot away from the ceiling. On the wall in front of me, there's a spider 1 foot away from the floor. So what is the shortest distance the spider can take to the fly by only passing around the ceilings, floors, and walls? So when I first saw this problem, my initial thought was, how do you solve this? Whether you're a college student or a middle school girl, visualizing this problem on a piece of paper can be extremely difficult. But who says math has to be limited to a piece of paper? Using a piece of string, we were able to model the paths the spider could take, using theories the girls had. We then translated that into a piece of paper, and compared our original theories to the ones we used with our string models. So the answer can be seen on the next slide above. It uses two math concepts: the Pythagorean theorem and nets. When the room comes flat in its net form, the shortest distance between the spider and the fly is the line that connects them. But the magic of this problem is that we arrived at this solution without ever using the word theorem. Using the string, using drawings, and using the girls' existing math knowledge, we were able to come up with the answer in the same way.
We recruited students from public middle schools in Durham for our workshops. We had 57 initial enrollees, 25% were 8th graders, 39% 7th graders, and 36% 6th graders. We administered a pretest that began with the Draw a Mathematician question, but was designed to assess a few key areas listed on this slide: raw math ability, math interest, educational and occupational aspirations, self-concept and self-standard in math, awareness and endorsement of gender stereotypes related to math, and social stigma related to math and femininity. One of our team members is also taking field notes during our workshops, focusing on her observations about interactions between the participants and our workshop leaders. We also plan on administering a post-test after our workshops to determine whether there are any differences in our students' answers.
So the program is still in its early stages, and we hope that the data from this cohort will inform us next year. However, the program will still remain in the same format for our next year. In the fall, there will still be the mentor discussion component, and in the spring, we'll have workshops leading into the summer. Additionally, we hope to expand beyond Duke. We hope through partnerships with other universities and programs such as the Duke Marine Lab, we can both broaden our reach and expand the number of topics introduced to our GEMs. Additionally, we hope to build a scalable model that we can use in rural parts of the states to expose students to programs like GEM that aren't already accessible.
Hopefully, after participating in our workshops, girls will be less likely to assume that a scientist or mathematician has to look like someone with crazy hair and glasses, and maybe someone who looks more like us. And here's our team. Thanks, everyone.
Thank you.